In this video, we'll talk about how the RPM system is organized and what major operations the RPM program can accomplish. We're going to explain the naming conventions used for both binary and source RPM files, query, verify, install, uninstall, upgrade, and freshen packages. We're going to talk about why new kernels should be installed rather than upgraded, how to use RPM to CPIO to copy packaged files into a CPIO archive, as well as to extract the files without installing them. As we know, the Red Hat Package Manager RPM is used by a number of major distributions, and they are close relatives to control the installation, verification, upgrade, and the removal of software on Linux systems. The low-level RPM program can perform all these operations either on just one package or on a list of a package. Operations which would cause problems such as removing a package that another package depends on, or installing a package when the system needs other software to be installed first, are blocked from completion, right? Advantages of using RPM. RPM is a package management utility developed by Red Hat. The name originally stood for Red Hat Package Manager. All files related to a specific task or subsystem are packaged into a single file, which also contains information about how and where to install and uninstall files. When developers create a new version of a program, they usually release a new RPM package. Be aware that these files may not be usable for other Linux distributions. For system administrators, RPM makes the software packages easy to manage. It is easy to determine which package a particular file comes from, which version of the package is installed, and whether it was installed correctly. It is also easy to remove complete packages to free up disk space. RPM also distinguishes documentation files from the rest of the package, allowing you to choose whether to install documentation on the system. RPM makes the software developer's job easier. Often, developers must change the code to get it to compile and execute correctly on another operating system. RPM allows builders to keep all the changes necessary for building on Linux separate from original source. This capability facilitates incorporating new versions of the code because build-related changes are all in one place. It also facilitates building versions of Linux for different architectures. Package file names. RPM package file names are based on fields that represent specific information as documented in the RPM standard. The standard naming format for binary RPM packages is name, version, release, distro, architecture.rpm. The standard naming format for a source RPM package is name, version, release.distro.source.rpm. Note that a distro field often actually specifies the repository that the package came from, as a given installation may use a number of different package repositories, as we shall discuss when we discuss DNF, Yum, and Zypper, which work at a level above RPM. RPM database and helper programs. var librpm is the default system directory which holds RPM database files in the form of a Berkeley DB hash files. The database files should not be manually modified. Updates should be done only through the use of the RPM program. An alternative database directory can be specified with the --db path option to the RPM program. One might do this, for example, to examine an RPM database copied from another system. You can use the --rebuild db option to rebuild the database indices from the installed package headers. This is more of a repair and not a rebuild from scratch. Helper programs and scripts used by RPM resides in user lib RPM. There are quite a few. For example, on the Red Hat 8 systems, you can take a look at it. They do ls user 25 here, right? And here, WC is reporting the number of lines of output. Take a look at it and where exactly this folder. You can create an RPM RC file to specify default settings for RPM. By default, RPM looks for user lib RPM RC, etc RPM RC, ~/.rpm RC. In the above order, note all these files are read. Right? RPM does not stop as long as it finds that one exists. An alternative RPM RC file can be specified using the --RC file option. Queries. All RPM inquiries include the -q option, which can be combined with numerous other query options. -f allows you to determine which package a file came from. -l lists the contents of a specific package. -a, all the packages installed on the system. -i, information about the package. -p, run the query against the package file instead of the package database, right? On the screen, you will see exactly what this stands for. I can explain them. The first one, rpm-q bash, is which version of the package is installed, right? -qf, this is which package did this file come from. -ql, this is what files were installed by this package. -qi, you're going to show information about this package. -qip is going to be showing information about this package from the package file, not the package database. Right? -qa is a list of installed packages on this system. A couple of other useful options are --requires and --what providers. The --requires option will return a list of the prerequisites for a package, while the --what provides option will show what installed package provides a particular requisite package. Verifying packages. The -v option to RPM allows you to verify whether the files from a particular package are consistent with the system's RPM database. Use the rpm-va command to verify all packages on the system. S is the file size differs. M is mode differs, permissions and file type. 5, MD5 sum differs. D, device major minor number mismatch. L, read link path mismatch. U, user ownership differs. G, group ownership differs. T, M time differs. In the output, you only see output of if there is a problem. Each of the characters denotes the result of a comparison of attributes of the file to the value of those attributes recorded in the database. A single dot, period, means the test passed, while a single question mark indicates the test could not be performed. Example, file permissions prevent reading, right? Otherwise, the character denotes the failure of the corresponding --verify test. no output when everything is okay. Let's see some examples. RPM-E dash. So no output, when everything is okay, right? Let's do RPM-V. I'll go rotate. This output indicating the file size, checksum, and the modification time has changed, right? Let's do sudo right? Okay, we do RPM-V log. You see this indicating that a file is missing, right? Move on. Installing packages. Installing a package is as simple as you do sudo rpm-ivh, give a name of the package you want to install, where I is for install, -v is for variables, and -h just means print out hash marks while doing, to show progress. So the tasks RPM performs when installing a package. You're going to perform dependency checks, performs conflicts checks, executes commands required before installation, deals intelligently with configuration files, unpacks files from packages and installs them with the correct attributes, executes commands required after installation, updates the system RPM database, right? Let's explain a little bit. The first one performs dependency checks. RPM performs dependency checks, right? This is necessary because some packages will not operate properly unless some other packages is also installed. Conflict checks. RPM performs conflict checks, including attempts to install an already installed package or to install an older version over a newer version. The developer building a package can specify that certain tasks can be performed before or after the install, right? Deals intelligently with the configuration files. When installing a configuration file, if the file exists and has been changed since the previous version of the package was installed, RPM saves the old version with the suffix .rpm save. This allows you to integrate the changes you have made to the old configuration file into the new version of the file. This feature depends on properly created RPM packages. You're going to unpack files, right? In addition to installing files in the right place, RPM also sets attributes such as permissions, ownership, and modification, build time. Executes commands. RPM performs any post-install tasks required for setup or initialization. The last one updates the system RPM database. Every time RPM installs a package, it updates information in the system database. It uses this information when checking for conflicts. Uninstalling packages. The -e option causes RPM to uninstall, erase a package. Normally, RPM-E fails with an error message if the package you are attempting to uninstall is required by other packages on the system. A successful uninstall packages, no output. Let's see an example. Sudo RPM-E system is not installed. All right, an example of error due to dependencies can be seen. Right, I do sudo test the failed dependencies, right? You can see here. You can use --test option along with the -e to determine whether the uninstaller will succeed or fail without actually doing the uninstall. If the operation would be successful, RPM prints no output, and the -vv option to get more information. Remember the package argument for the erase is the package name, not the RPM file name. Okay, next, freshening packages. The command sudo rpm-fvh *rpm will attempt to refreshen all the packages in the current directory. The way this works is, if an older version of a package is installed, it will be upgraded to the newer version in the directory. If the version on the system is the same as the one in the directory, nothing happens. If there is no version of a package installed, the package in the directory is ignored. The -f option is useful when you have downloaded several new patches and want to upgrade the packages that are already installed, but not install any new ones. Freshening can be useful for applying a lot of patches, i.e. upgraded packages at once. Upgrading the Linux kernel. When you install a new kernel on your system, it requires a reboot, one of the few updates that do to effect. You should not do an upgrade -u of a kernel. An upgrade would remove the old currently running kernel. This in and of itself will not stop the system, but if after a reboot you have any problems, you will no longer be able to reboot into the older kernel, since it has been removed from the system. However, if you install, both kernels coexist and you can choose to boot into either one, right? I.e. you can revert back to the old version if need be. To install a new kernel on a Red Hat based system, you do sudo rpm -ivh kernel-version.arc.rpm, right? Put in the correct version or architecture names. When you do this, the grub configuration file will automatically be updated to include a new version. It will be the default choice at boot, unless you reconfigure the system to do something else. Once the new kernel version has been tested, you may remove the old version if you wish, though this is not necessary unless you are short on space. It is recommended that you keep one or more older kernels available. Using RPM to archive and RPM to CPIO. RPM to archive is used to convert RPM packages files to tar archives. If dash is given as an argument, input and output will be on stdin and an stdout. First line on the screen is convert an RPM package file to an archive. And the second one, extracting one step, right? How you gonna tells you how to extract in one step. It's more direct and efficient than the older RPM to CPIO utility, which can be used to convert package files into CPIO archives or to extract files from the package file, right? The third line is convert an RPM package file to our CPIO archive. The fourth and fifth line are, extracting one or more files. The last line is the list of files in a package, right? So when doing so, all files are extracted relative to the current directory. So if the user is in the home student directory and extracts the bin bash file, as in the example above, it will be stored in the home student bin bash. If all you want to is list the files in the package, the easiest method to use the RPM command itself, either rpm-qilp package.rpm. Okay, this is the end of this video. Thank you for watching. I'll see you in the next one. Bye for now.